My name is Osa Gaius. I work for a company called Luma. We do stuff. That stuff seems to be kind of cool right now. And today, the kind of discussion will be around building real-time web apps with React and Elixir. Some of you may not be familiar with Elixir, some of you may, and some of you may not be familiar with React. So feel free to sort of stop me, interject, and we can sort of take it slow. So the general outline for the talk today will be sort of first an introduction, followed by a discussion around functional programming and reactive programming. And then we'll move to UI, talk about React and Redux. And then quickly move on to Elixir and Phoenix. For some of you that may be completely new. We'll talk a little bit about RethinkDB, which is the data store in this case, do a short demo, and then we'll conclude. So in terms of introductions, the obvious question is why, right? So why give a talk about real-time web apps? Why does any of this matter? Why waste your Tuesday evening listening? And I think that there are a couple of reasons. The first is there's an increase in demand for these kinds of real-time web apps. And this generally has to do with what users expect from products that we make today, what they expect from user interfaces. Most users expect experiences like Google Docs, experiences like Gmail that are interactive or collaborative. So they want to type something and expect it to just be, right? And that's radically different than the kinds of apps you were building 10 years ago, the kinds of apps that even today in the enterprise are considered normal. So here's sort of a very simple example of what, maybe a trivial example like Excel, for example, that, someone is typing. But most users expect when they type something for something else to happen, right? Even if it's something that's completely trivial. They expect that to be the case. And so this is a sort of change in the demand that our users expect that also changes the way we build apps. The second, I think, is the unprecedented scale. And by scale, I mean here, you as an individual developer, as a person in a startup or a company, has the ability to affect thousands, if not millions of users within a short few months, right? So that changes the kinds of experiences that you have, not just for one person, oh, this is cool, for one user, but what tens of thousands of users will always expect from you. The third is that there's a rediscovery of old paradigms. And by old paradigms, I mean ways of making things, right? Ways of doing computer science. So things like functional programming, reactive programming that went out of style for maybe 10, 20 years in the advent of object-oriented programming are starting to resurface because we have unprecedented scale as well as a change in what users expect. The last is obviously sanity, right? I think that when you think about most applications at scale, particularly UI applications, they look like this. I was just having a conversation with a gentleman here who mentioned he has a sort of app built over 12 years that is utterly crazy and utterly unmaintainable, and I've experienced that, right? Your apps look like this, your UI looks like this, so no one wants to touch the UI because it's so complex. You change one button and the entire app falls down, right? So what is the sort of alternative to that? My alternative is to think about your UIs and, in fact, your entire application as just this, right? So instead of this, can we build applications that at the end of the day, 10 years, 20 years down the road, look more like this, right? Because this is how applications get started, but often, more often than not, they end up looking like the latter. And so my sort of argument is that if you think about your data, right, it's flowing through the dotted lines, flowing from your data store up to your interface, and then commands on the top flowing back down to your data store, then you can sort of change how you think about your application, and we can walk through that a little more. In the context of this talk, sort of how we're going to approach this is we're going to think about our user interface has been primarily React and Redux. We'll think about our server as being Elixir and Phoenix, and we'll think about our data store as RethinkDB. And I'll kind of walk through why I think these choices are particularly poignant, but generally I think this sort of architecture for your applications or your user interfaces are going to be quite interesting around maintainability and testability. So with that in mind, let's kind of talk a little about functional programming. I'm sure most of you are sort of familiar with functional programming if you took computer science courses or you've been programming for a while. But I'm really going to try to draw out certain points from the functional programming idiom that make sense when thinking about building robust real-time web apps. So the first is functions, right? So how do you think about functions? Functional programming is all about functions. It's all in the name. But I think the driving sort of difference is the difference between an impure function and a pure function. So if you think about an impure function, like the one on the left, if you take the function square, yes, it does take some input, and it returns some output, which is the square of the number that you gave it. However, it also does something dangerous. It changes the state in the world, right? It has a side effect. In this case, it goes and it updates in a database some value x. What does the update in the database function do? No idea. And in fact, most applications that tend to increase in complexity and tend to be inherently untestable look like this. It's a very naive change. It's not really that bad, but it doesn't scale very well, and in fact can come back to haunt you. Now, by contrast, to your right, there's a pure function, right? It's a function, square. It takes an input. It returns the output. It does nothing else. So when you call that function, you can be certain that nothing else in the world changed, right? And that can be quite useful when you think about, tens of thousands of functions that are doing tens of thousands of different things. You can then reason that after you run all those 10,000 functions, you would only get back 10,000 outputs. No other change will happen as a result. The second part of functional programming that to me is really interesting in the context of building real-time web apps is state, right? And state generally, for me, means what is the truth in the context of your application? What is the truth in the context of your component or even your function? Functional programming argues that you should have immutable state, right? Like your state should not change in the context of executing a function. So your function should be pure and should not change the state. It also argues that you should think about state, so that even if you are going to mutate state in some way, you should be explicit about, I am going to do something terrible, and that's okay, or I'm going to update a database here, and that's okay. And lastly, it discourages you from sharing, which, your mom might have told you that sharing is caring, but in the context of building applications, it's actually really terrible to share. Because when you share, you sort of introduce problems like how do you make sure that two processes aren't accessing the same data at the same time? How do you, resolve these kinds of issues? And that usually tends to result in using like locks and semaphores or just having terribly complex applications in the first place. Now, functional programming is interesting intellectually, but the obvious question I think most of you are asking is like, so what, right? What does this mean for building real-time web apps? Why should I care about functional programming, which is kind of old school, kind of computer science beard kind of thinking? And I think the largest argument is that functional programming, or having pure functions, squashes complexity, right? So if you think about complexity in your application, a lot of complexity, a lot of bugs come from something happened that I didn't know was going to happen, right? Whereas a pure function that takes in some input and returns some output, it's always going to return the same thing given the same input. And so there is no complexity there aside from whatever computation you need to do. The second is that sharing, like I said before, is inherently bad. Because sharing is what produces the graph I showed earlier, where you have a bunch of complexities, a bunch of dependencies between your functions because they all go and do other things to other things. And that kind of sharing in the context of building applications, especially as applications become increasingly real-time, are going to be hard. Because now you not only have to share, you also have to think about time with regards to sharing. So what is this function at this time? What is the state of my entire application at this time? So those are the two sort of whys when it comes to functional programming. Any questions before we move on there, or objections? Okay, so now that we agree that functional programming is awesome, the question is, what is reactive programming? It's one of those terms that I heard a lot in school and professors sort of talked about and were like, yeah, don't worry about it. It matters, but not really. And I came to rediscover reactive programming recently because I think it's one of those old school idioms that really pays dividends. So there are three ideas from reactive programming that I think you're probably already familiar with, at least intuitively. The first is data flow, the second is change propagation, the last is streams. So data flow simply means that data in your application flows from one point to another, right? There is some data flow. There is some source of truth, and all other things receive their data from that source of truth. And when something changes, it returns back to the source of truth and again flows back. Now, the challenge here, I think, is most of us think our applications is like, these sort of entities that are inherently changing. But in fact, if you think about it, there's really only one source of truth, and everything sort of flows into that. Now, the second is change propagation, right? So if there is some data flow, right, either top to bottom, right to left, whatever you sort of use, the second is that change should indeed propagate from one source of truth to the rest of the application, right? And what that means in the context of streams is, if you think about a series of click events, right? Someone's clicking their mouse. How do you model a series of click events over time? The easiest way to do that is as a stream, right? A stream of things that are happening, and then you can say, let me map over that stream, do a reduce over that stream. But the stream is inherently finite. It starts at some point and ends at some point, right? So the argument I think I'm making is that we should think about our applications more generally as a sort of reactive flow, right? There should be some data flow in your application. If you can't draw your data flow from your application in a line, whether it's a vertical or horizontal line, then you're not thinking about data flow, and your data flow is inherently complex, right? And you can't really model that in a way that is easy to reason about. So With that in mind, I think it's important to then talk about the UI, right? So React and Redux are sort of what we spend our time on here because this is a React meetup. And I think they, in particular, provide really useful tools around functional programming as well as reactive programming that make a lot of sense. So the first is React. React is, I think I want to make the argument that React is not reactive, but I think that, sells React short, right? I think React has all the building blocks to build reactive and functional applications, but I think, I'll sort of caveat that by saying you got to be careful, right? And by reactive, I mean that because React sort of has this virtual DOM or shadow DOM, it encourages you to think about your application in context of data flow, right? So you build components, and those components change over time because they receive new props. And so you can think about the reception or the provision of new props as sort of a kind of data flow. Your data is changing, your props are changing because they're being rendered. The second is that React is inherently functional precisely because it's built up of small functions, which are called components or UI components. And we can take a look now at what that means. But I think all of sort of centers around the fact that you have a virtual shadow DOM, which essentially means you don't actually alter the DOM, you don't touch the DOM. Instead, you simply render your UI components, and React itself takes care of deciding how those should be rendered to the DOM. Now, so in terms of describing what this looks like in real life, if you think about sort of old school jQuery code or even like JavaScript code from back in the day, a lot of what you would do is to the left, right? You would sort of make a bunch of changes to the DOM, like hide this element, show this element, remove these header tags, so on and so forth. In the context of React, you simply say, make all those changes, make them true, and then React takes care of actually going ahead and changing the DOM or re-rendering the DOM. And while that doesn't seem efficient, it actually ends up being, one, efficient because React optimizes around this, but two, very easy to reason about because you can only reason about the functions in your applications as opposed to how the DOM actually gets changed. Now, the second thing that I think is really important about React as opposed to other sort of functional or even front-end languages is, components are inherently functions, and that's how I could think of them, right? A component, if you think this case, hello message, simply has one thing that it does, it renders, right? That's the most important method. It renders some HTML to the DOM. And what's unique about this is that the props, in this case, are the input, right? So irregardless of, put differently, if you provide the same props to a component, the component should render the same output every time, right? The same HTML should come out of your component every single time. And that's inherently functional because you can reason about the world, and you could say, if I supply this component some given input, it will always return to me this output, and it will not change the rest of the world. It won't go update the database, it won't do some random thing, it won't change another component or modify the DOM in some other way. And that's really useful because then your entire application can be composed of these components, and you can reason about them separately as opposed to as one gigantic blob with a series of connections. And then React has, smart components which, do reach out to the world and do know how to do things. But I think I'd like to emphasize that, basic components that do nothing, that just take some input and return some HTML are sort of the building blocks that make React, necessarily reactive and also functional. Now, the sort of second part of the UI that I think is really interesting is Redux, right? I think one could make the argument that React is not necessarily reactive or not necessarily functional, but you can't say that when you reason Redux because it sort of forces you to think about your UI reactively as well as functionally. So let's take a look at that. So React, sort of came out, and then Redux sort of came about as a state container to think about, how you manage state in your UI. It's inspired by Flux, Elm, and reactive extensions, which are all very interesting, Elm in particular, because it's a functional and reactive programming language itself. And so the key takeaway from Redux that you probably already know is this idea of global state, right? So, it's true that your apps have to share in some way, particularly in the UI, right? Like, if you go fetch some data from somewhere, where do you store that data? If you have 5 components that you need to use that data, right? And so what people end up doing is they have to store that in one component, and then other components also fetch it and sort of pass that around, and they share that. But in Redux, the argument is that you should have one global state, right? One global store of all the information that all of your UI components, all your views need to show, right? So the global state then becomes your source of truth, right? It's read-only, which means the only way to change it is through functions, right? So inherently, you're now being forced to use functions to change the state of the world, right? As opposed to having, a bunch of data that you're sort of moving around. The last element of Redux I think is interesting is that it's architected around, one, thinking about data flow, but more importantly, a unidirectional data flow, which means that data flows from one part of the application through to the rest, right? And whenever something changes, that source of truth changes and everything flows again. So pictures are worth 1,000 words, and in this case, that's true. So if you look at this sort of diagram, the key component here is the store, right? Your store, in the context of Redux, is the source of truth, right? It's that global state, right? And as you're familiar with, if you think about, what happens to the store in the course of applications, is that, you want to make changes, right? Someone puts in a text field, or someone says, I want this new document, or someone says, go get me some data from an API. And what happens is that your store gets updated, right? And as your store gets updated, because your store is what feeds your views, what the user is seeing, whenever your store is updated, your views are automatically updated, right? Because they depend on each other, right? The view depends on the store to render itself. Now, what sort of happens then is, if you think about a sort of click event, someone clicks on a button on the view and says, okay, I want to see this other thing. Instead of directly updating your store or the view going out and fetching from some API, what instead happens is your view triggers some action, right, which itself is a function, right? And that action then causes a dispatch event to happen, and then the reducer, which in this case is how the store gets updated, decides, okay, this action has been taken. How do I update the store now? Do I go fetch some data and store it in the store? What do I do? But this sort of data flow is interesting because, again, it's unidirectional, right? Your store is where everything is stored, and instead, everything just flows from there. Everything flows into it and flows out of it. But you can reason about that flow in a way that is pretty useful. The other thing to draw out here is that these are sort of black boxes, right? Each of them are sort of functions. They take input and return some output. And so you can reason about each sort of part of the application separately. You can reason about your actions separate from your producers and separate from your store, although they sort of share data, or rather, although they interact with each other, they don't sort of share data explicitly. Any questions before we move on to the meat of it? Go ahead.
In the previous slide,
yes.
What stage does the I/O or API call out?
So generally, that happens in your action, right? So someone dispatches an action by clicking the button, right? They click the button, and so you dispatch an action that's like, go fetch me this user's profile, and your action then goes out and does that. After your action completes, it then dispatches another event and says, hey, I succeeded in getting this thing, and that gets handed to the reducer, and then the reducer takes care of, okay, here's this data I got back, let me update this in the global store so that every single view that depends on that profile can just re-render automatically, right? And you get all the re-rendering for free because React, right, re-renders every time you get new input. Any more? Cool. All right, so now we're going to jump into the Elixir Phoenix part, which for most of you, I'm going to assume is the new fanciness that makes all this interesting. So Elixir. Elixir is built on the Erlang virtual machine, which if you're not familiar with, was created by Ericsson a long time ago when people still built telecommunication infrastructure, right? And so they built this sort of beautiful virtual machine and beautiful language because they have this problem. People's phone lines should not go down, right? In theory, you should be able to have high availability when it comes to, large-scale telecommunications infrastructure. And Ericsson built the Erlang VM and was able to see something like 99.99999 essentially availability over their clusters. And some of their clusters are still running in production today after many, many decades. So essentially the case in point there is that fault tolerance is the key point when it comes to Elixir, right? It's a language built around fault tolerance, around building systems that are able to survive at scale, survive failure. So if they crash, they should handle that crash in a way that makes sense. The second sort of component is processes, right? The Erlang VM operates around processes, and processes are small units of computation, very similar like OS threads. However, they're different in the sense that they all run in the virtual machine, right? And because they are small processes and they don't share any state, right? They're inherently functional processes. Because of that, you can spawn thousands, millions of these processes that go do some computation, right? And then return some result. Now, what's interesting about those is that because there's no shared state between them, those processes have to communicate with each other in some way, right? So if one process goes out and fetches something in the API, how does it communicate with the process that called it, right? So message passing is the only way to actually function in the Elixir world, the Erlang VM. So you pass messages to processes, and these processes are inherently decoupled, and so you can reason about the processes separately. And it has garbage collection, which manages the sort of death of the processes as they go away. Now, what's interesting about processes, right, a thing of processes in this way, is that it makes possible something that you can't really do in other languages, which is supervision. And supervision generally refers to both a supervisor and a worker, right, which are all both processes, but essentially allows for one process to supervise, in other words, manage the life cycle of another process. And if you think about this in the context of this sort of slide, you have a supervision tree, which is what this sort of is. Now, the green are what we can think of as supervisors, right? They supervise other processes, and the blue are workers. They go out and do work, or they perform some computation over the course of a lifetime. And what's unique about that is if one of these processes, that is a worker, dies, it is restarted, given some mechanism by the supervisor automatically, which is precisely how you're able to get high availability, especially in real time, right? Because things are sort of happening, a process crashes, as opposed to that process, just taking on your business or losing you billions of dollars, that process should restart, right? Now, what this allows you to do is sort of build the application as opposed to defensively or just not caring about it. You can build the application by letting things crash, right? You let things crash. In this case, if you think about this example to your right, process number 2, there in the middle, crashes for some example. It is restarted by a supervisor, the one above, and you now have the same application. This sort of restart, because it's at the process level in the virtual machine, can happen almost instantaneously, right? Within seconds, milliseconds in some cases. So you can sort of think about your applications as processes that when they crash, they restart, which tends to be quite useful in the context of real-time apps, because you don't have to build a bunch of defensive mechanisms around if this thing crashes, then do this, then do that. It just sort of happens naturally for you, and so you can reason then about other parts of the application. Now, in terms of what does code look like, this is all you have to do to define a supervisor and define a worker, right? So some supervisor, this is a general supervisor, has 2 children, one of whom is a supervisor and one of whom is a worker. So if at any time, if the TCP pool crashes, or the TCP acceptor crashes, those will both be restarted, right? And you can also define arbitrary workers and supervisors to also nest under this. And strategy 1 for 1 down there is interesting in regards to this example, because it says, if any of these processes crash, only restart that process, right? Don't kill the entire application, just restart the one process that failed. So the sort of other part of Elixir that's really useful, obviously, is that it's a functional language. It gives you functional programming idioms for free. It has sort of an elegant style. In this case, you can take a look at define serve drinks, and what you're doing is you define a function that does something, and it should be idempotent. It should change the state of the world. The second is that it has pattern matching, right? Pattern matching is what we're leveraging here in the first function, define serve drinks, get some user. What we're actually doing there is we're taking the age from the user object, right, as it gets passed into us by matching against what the object should look like, and then we're using that value to do something else, which lends itself to quite elegant code when you get around to writing. The last portion of Elixir I'll talk about is around extensibility. So it's a language that allows you to write macros, which if you're familiar with Lisp or languages like that, macros are quite useful because it allows you to extend the language itself and build tools around that, which lends itself to domain-specific languages that can be quite helpful as you write code. The last is tooling, right? Tooling around Elixir is actually quite fantastic. You could think of Elixir as very similar to Rails in some ways, right? Like it emphasizes developer productivity above all things. And so Mix is a quite helpful tool that lets you generate new projects, generate even schemas for your JSON, or even generate an entire database schema at the same time. And IEX is REPL, where if you've used Clojure or any useful Lisps, REPLs are quite useful in that case, and Elixir kind of gives you that. You can even have an interactive REPL on your production code, so you can debug your production code as it's happening, and that can be quite useful. So any questions before we move on about Elixir? So let's talk about Phoenix. Phoenix is probably the first place people start, and they kind of work backwards. They discover Phoenix, and then they're like, wait, Elixir, and then Erlang. And then they quickly come back up to Phoenix. Phoenix, for me, is really interesting because it's supposed to be, what Rails ought to be, right? It's very strictly modeled off Rails, while Elixir is sort of, subtly modeled off Rails. Phoenix gives you everything you could think of in Rails, except, built on a really nice functional language. It's built on Elixir. Interestingly, it's simply a series of macros built on the Elixir language, and that is very, very nice because you can also extend Phoenix as well as extending Elixir's functionality. It implements the NBC pattern, which you're familiar with, like every other language. We will skip that. It provides controllers. I don't care about controllers. You know what those are. You can dispatch things. However, we're going to talk about channels, right? Because channels, I think, are where the real-time component comes in. That's why I think Phoenix is much more useful for building real-time web apps. So what are channels? Channels are an abstraction over WebSockets, right? So if you're familiar with WebSockets, it's simply a way to have a long-lived connection between one client and one server. But what's useful about Elixir, or particularly Phoenix, is that it provides this whole library around how you do this. Very similar to socket.io, if you're familiar with that. But it provides a couple of key other mechanisms that can be useful. The first is it provides routing, which we'll talk about pretty soon. It provides presence, which is perhaps the most cutting-edge feature, and it has several client libraries, right? A library for iOS, a JavaScript ES6 library that you can use in your React Native or your React applications. And we'll be using the latter of those, the JavaScript app, pretty quickly. So, routing is kind of what I described as being this sort of killer feature, right? So if you think about your WebSockets, they're pretty hard to reason about, right? There's a WebSocket connection between a client and a server, but like what is really happening? In context of Phoenix, you can just establish a WebSocket connection. You define your socket, give it a name. But you can define a handler for the connect event, right? You could say, when someone connects, they have to give me a user, right? And you're pattern matching against the user. And then you're saying, assign this user this socket. Done. But more importantly, you have the ability to define channels, right? You can define a channel, which is simply, sort of a pipe within your socket, right? Or a routing mechanism, or think of it as a controller within your socket, right? And you can define some channel. You can give the channel a name, right? You could say, this channel is going to be called rooms, right? Or rooms in this case. And you can then, pattern match against different rooms, right? So let me say I want to have like 25 different rooms, kind of like Slack, right? And then you can define some method or some class that's going to handle the connections to this channel. And that's really it, right? Now you have a connection, and you can have many sockets, and they're all multiplexed for you. And Phoenix also handles all the failure if a channel dies or something like that happens. Now, what does this look like on the JavaScript side, right? So like I've just asserted that you can create a WebSocket, and you can create multiple connections, and channels and words are coming out of my mouth. In the context of JavaScript, this is just like some React or ES6, whatever code you're using. All we have to do, because Phoenix provides its own library that connects directly to its own channels, you can simply say, define a new socket, pass it the parameter that I know I should pass it to join this WebSocket, connect to the socket, and then join a particular room on that WebSocket, right? And you're done. In 3 lines of code, you've just created a WebSocket, and now you can do whatever you want to do with that WebSocket. And you've joined a channel, more importantly, and so you can pass messages. So essentially what happens is you have this module, right? In this case, we're going to call it a room channel that someone can join. And what happens when they join is you define a join handler to handle a join event. And in this case, after we join, we send ourselves, right? We send ourselves, the process running this particular WebSocket. We send it a message saying, go ahead and handle someone joining, right? In this case, we're just responding with like, okay, you joined, and then we're sending a message to ourselves. What is this like in JavaScript, right? In JavaScript, it looks like the same thing, right? You say channel.join to join that channel, and then you say, if I receive an okay, say yay and do some other work. And if I receive an error message, cry and call your mom. Now, it's pretty idiomatic, right? Because you have the ability to quickly join a socket, and you can reason then about, on your front end, what it looks like to actually join the socket, and all these handlers are defined for you. Now, the question is, what happens when someone does something, right? Because that's the only reason WebSockets are useful, is for passing messages and then routing those messages to where they need to get to. In this case, if someone has joined a particular channel on the WebSocket, let me say they've joined the room lobby, and they send a message on the Elixir side on the top, you simply get an event that happens with the particular tag, a new message, and you then do whatever you want, right? Like write the message to a database, or save it in Redis, whatever you want to do. And on the JavaScript side, in 1 line of code, you do the same thing, right? You simply push a new message, right, which is the event type, and then you pass it a body, right? And on the top, you can do whatever you want with that message. And really, that's the bulk of channels, right? Is it gives you WebSockets, right, as an abstraction, and then it gives you channels, the ability to route, right, within the WebSocket and reason about those things in a way that makes sense. Now, the portion of Elixir, that Phoenix rather, that I think is quite useful, that this is like 3 months old, it just got released, is presence, right? So you think about, WebSocket, and the common problem is, let's take the Slack example, right? How do you know that your coworker is online on their mobile device? That's a really hard problem to solve, right? It's an extremely hard problem to solve if you ever try to solve it. Phoenix kind of gives you this for free, right? And it's called presence. It's an abstraction, again, built on that layer of WebSockets and channels. So it says, essentially, if someone joins a WebSocket, right, you can, in addition to handling the join event, you can get a bunch of metadata about, when were they online, what browser they come from, right? So you can pass a bunch of information about that join event, and you can then maintain that over time. It's eventually consistent. It's built on CRDTs, which means that over the course of your application, it will eventually be true that you have information that is eventually true about every single person who's connected to your WebSocket. So if you have 1 million, 2 million, it doesn't matter, it eventually will be consistent. The last is it's highly distributable, right? Because again, Erlang virtual machine is built to be fault tolerant, but also scalable across machines. It means that you can have 20 different servers, right? All running Phoenix, all running Presence, and you can have different users connected to 20 different servers, but they all will have the same information about who has joined, right? And you get that for free, right? You don't have to spin up some Redis instance to store that information. It's just there. Now, the sort of obvious question is like, how does this look? Like, is this a lot of code? But this is all you need to do to have web presence for all your connections. You simply say, after someone joins, which, as we saw earlier, is the message that you send out to yourself after a join event happens, you say, track the presence of whoever connected to this WebSocket, right, using their username, and then, track when they were online, right? Just add some information that you want to add. In this case, you could add like what device they were online from. You could add their location, and that will be distributed to every other person who is connected to the WebSocket as well. And then you push that back to everyone and say, hey, someone else has joined, right? Or the presence has changed. And then, whoever is the client can deal with that in some way that's, makes sense for them. One last point is that what we're doing there is presence.list, which just takes the current presence, CRDT, and then just lists it all, right? And then we send that back to who the clients are. On the JavaScript side, it's also equally simple or mundane. You simply define some way that you're going to store presences. In this case, I'm just going to use like some random object. And then when anything happens that changes the state of the presence, this client will get a message saying present state. And it will get a payload of state, and then we can dispatch on that. And we can use, again, the JavaScript library for Phoenix and say, sync the state, right? Take the current presences that I have, and then take this new state that I have, and then sync them together, right? So that now I have a true representation of what the world looks like. And the same thing happens if someone leaves the socket or joins the socket or something crazy happens, you get a diff. You can diff that, and you can sync the diff as well. So before we move on to Rethink DB, any questions about like presence? That was a lot of words about presences and listings. Everyone good? Okay, so the last part of this that I think is going to be interesting is Rethink DB. Rethink DB is a JSON data store. It's open source. It's quite interesting. And it has a couple of features that I think change the way that I want to think about how we build applications. So the first is it supports joins. That's like interesting, vice versa to like MongoDB, which is quite useful but doesn't support joins. And having joins means that you can sort of do a bunch of data manipulation quite easily. It has an interesting query language called Requel that allows you to query your data, do mapping and reduces. But it's also native to your client. So if you're using like Node.js or you're using Meteor or something like that, it has a JavaScript client. And the concept of Elixir, it has an Elixir client that has all the functional programming idioms kind of built in. And so you can think about your database and write your queries in a very functional way. The third is that it has an admin interface, which is like really, really good. Lets you like shard your database from a UI, like do a bunch of replication, and see what's happening in your data. The most important thing, though, is change feeds, right? And we're just going to spend a bunch of time there because I think it's perhaps the largest feature of Rethink that changes how we think about applications. So change feeds, it's all in the name. And I mean that in a sort of double way. One is that you feed changes to other things. The second is that it forces us to rethink how we think about a database. I had a conversation with a friend recently, and he sort of thought this struck him as interesting. We think about databases as places where we dump things, right? Like, dump it in the database, right? Like, tune the database to make dumping faster or slower or whatever. And instead, I think Rethink DB, particularly change feed, says, no, your database isn't a place you dump stuff. It's the source of truth. And so everything, which, I mean, this is like a fact, it's a source of truth, everything should rely on the database because they already do. And instead, the database should be declarative. It should say what is the truth, right? It should simply feed things to other things. And this brings us back to our conversations about data flow earlier. So how do you think about data flow in most cases, right? Things write to the database, right? They write to the database. But then they call the database to get things back. So how is data flowing, right? Is it flowing this way, that way? In many cases, it's like, kind of circular, right? You're doing this kind of thingamajiggy, then you're storing some data on your server, and then you're caching some things in a server. And so you kind of have this sort of psychosis where you don't really know what's happening in your application because you don't have a data flow that happens. So here's the proposition. Your database, in this case RethinkDB, is a source of truth. It's a declarative. And so when anything changes in a database, your database tells the rest of the world, this is now the truth. And the rest of the world reacts to that, right? In a reactive way, right? And in fact, if it's a React app, it reacts. And I think that's an interesting paradigm change, right? Not necessarily radical, but I think many of you are already doing this in your own work. But I think thinking about your application from the start as this is the way it's going to work, everything is going to flow from the database upwards, and everything will react to that change, is a radical way of thinking about your applications. More importantly, I think with with change feeds, you can actually do this in a way that's scalable. You don't have to use Postgres triggers or some other wanky mechanism, or even pull your database and get yelled at by your architects. You kind of have a simple way to actually do it that makes sense, because whenever the database changes, it simply emits those changes to say, hey, this thing has changed. So in practice, what does this look like? So what you can do in RethinkDB is you can watch for changes on an entire table, right? Database, whatever you think about it as. But you can also watch for the changes to a query, right? So if the result of this query changes, send me an update, right? In this case, this is the JavaScript client. We're saying if the users table changes in any way, send me the change, right? And the change, what you get sent, looks like the line below. An old value and a new value. In this case, the database did not exist. I mean, there's nothing in there. It was nil. And then we added some user. Someone added a user. I don't know who it was. And they added a user named Slava with age 31. And now you get that. And so you can then say, OK, let me pass this along to my UI. Let me cache this for people asking about it later. Let me delete it because I hate Slava. Whatever your use case is, you can define a bunch of event handlers that are reactive based on changes to the database, right? So before I move forward, I think a couple of caveats. The first is that, is this scalable? That's a big obvious question. RethinkDB spends a bunch of time thinking about how you scale this. So it's quite scalable, and they have a bunch of mechanisms around sharding your database when you have too much stuff, so that you can still support change feeds at scale. And the last is that, going back to this diagram, again, I think the driving point is it changes how you think about your application, right? If everything flows from RethinkDB, which is the source of truth, when something changes, you have a channel, right, which is connected to a client in some way, and you push the changes to the channel, and the channel is responsible for telling the UI, hey, something changed. The UI never asks what changed. The UI never says, what is the state of the world? The UI simply gets told the state of the world. And I think that's the sort of radical thing. Now, on the top, you kind of see this line in bold, right? The line in bold refers to, an action, right? So the user clicks a button, or they type in their name and says, my name is no longer Slava. My name is now, Jose, right? Because, I moved countries or something. In this case, the UI tells the server via channels, hey, I want to change my name. And the server tells the database, this guy wants to change his name. Now, what doesn't happen is you don't then, again, ask the database, what's my name now? Or you don't say, give me my name back when the name changed, and so RethinkDB emits a change. The channel emits that change to the UI, and voila, you have, optimistic UI or real UI in this case. No polling the database, no fancy magic, no caching stuff in the UI. It just kind of happens because you have this flow happening. Any questions before we move on about the flow? Yeah, go ahead.
I do. So, you were talking about the whole circular thing where, in a typical application, you have things querying the database, and you have, things being read to the database, so there's constantly changes, right? So you're talking about this flow from RethinkDB where it's basically leaving the things, right?
Yeah.
Some sort of change out. But there's got to be a query at some point to initialize the state, right? So you're still going to have some sort of flow. So,
of course.
I guess it's not clear to me, when you first start, you give it some sort of query that say, I want you to monitor this particular query. And then anytime something happens that would have affected that record, that's when it starts emitting the stuff?
Precisely. And what we'll see in a second, if we go back to, I mentioned supervisors and workers, right, in the context of Elixir, right? You have a supervisor that is the application, you can have workers. In the context of Elixir, you can define a worker and says, this worker's only job is to watch for changes on this table, or this worker's job is to watch for changes to this user's record on the table, right? And so when you start your application, you initialize that, right? And then whenever it happens, that worker, because of the process, just gets fed that data. And your answer to the first part of your question, there still is some, you still have to query the database at some point, right? But the change is, if the server, right, queries the database, right, that change still gets pushed, right, to the client, right? It's never as if the client is waiting for some result or any of that magic or spinning a wheel, right? You could spin a wheel, but there's no blocking happening anywhere in your application, right? And I think that's sort of the core difference. So let's do a demo, or let's attempt a demo rather, and see what it looks like. I was going to live code, but I've seen that go awry, so let's not do that to me. So we'll take a look at an application that I've been working on to demonstrate some of these ideas. So we are in a repo that I've been working on. We're going to say mix Phoenix server. Here we're using Mix, like I mentioned before, as a build tool for Elixir. Phoenix is the application, which is built on top of Mix, and then server just says run my server. And we'll serve a static page that has the JavaScript assets similar to how other things work. And what this is doing here is starting my application, starting Webpack, and building the application. Voila, application is now running. So let's take a look at what's sort of happening in the application. So we'll do a side-by-side because this is fancy. Can everyone see in the back? I assume yes. So this is the quintessential chat application, right? We're going to chat with all our friends in the world. And so to join, we'll simply type a username, let's say OSA. And we'll see sort of three parts of the UI. The first is a list of messages. The second is who's online currently. I'm online. And the total number of messages, which represents all the messages in our database, right? So what happens, though, if someone else tries to join? Actually, first of all, let me add a message and just say, like, OSA still has great hair. Cool. And let's try to join again. Let's join as Taggart. So as you can see, the list of who's online has changed. Nothing else has changed in the application, right? Everything's still good. What if we join as someone else, right? Just to demonstrate that this isn't like a cache or something, like a cheating situation. Let's join as Kinsley, which is a Haitian name, very popular at least. And now we have 3 people online, and it's all synced between all the different clients. Let's put a message in, though. Let's put a message in from this user, Taggart, and let's say Taggart is awesome, which is true. And every client gets the message, voila, voila, magic. So this is an example that I thought was interesting because it's quite simple. I think all of you can probably build this in like a few hours. Like it's straightforward. But I think it probably demonstrates a lot of what's happening. The who's online is some sort of state, right? This is the presence. Who is here in the WebSocket? The messages are what is the truth in the database? What are the messages? And the total messages are like you saw updated down there are what is the truth about the messages again. So let's take a look. Any questions before we go into some code and like really dig in? Okay, let's dig in. So how is this happening, right? How is this subtle magic happening? The first I think is this is your high-level application for your Elixir code, right? This is your Phoenix application. It has a supervisor, like a meta supervisor, and that supervisor has in this case 4 children, right? The first child is the endpoint, right? It's where you serve your assets from. It's where you serve your various controllers from. It's an endpoint. What's useful about the fact that it is also a supervisor is that it can have multiple children. So each route can be its own child. If any route fails, that also gets restarted for free. It has a second supervisor as a child, which is the presence, which, as we discussed, maintains the state of whoever is joined to your WebSocket, what channels they're joined to, as well as their meta information. Third, it has a worker, which is your RethinkDB connection. So if your connection to RethinkDB fails, right, your connection to a database fails, it simply restarts the connection, right, for free. And lastly is it has a worker called post-change-feed that is responsible for watching for changes to your posts or your messages database in this case. So let's take a look, first of all, at what happens when someone joins the channel, right? You've already seen some of this because I cheated and I put it in the actual talk. But your room channel is kind of where the magic happens, right? When someone says, I want to join a room, you simply send yourself a message that says, someone has joined, do some work, right? In this case, what we'll do is, as we've seen before, we'll track this person who's joined, and we'll track when they came online just for, for giggles. And then we'll do what you mentioned earlier, is we'll actually then go create the database, and we'll tell the database, go ahead and give me the last 20 posts this user submitted or that was ever submitted, and then store that in some variable, and then push that down to the client, right? So as you saw in that example before, the server goes to the database and says, give me some information, and then is responsible for propagating that, right, through the data flow all the way back to the client. And so the client, as it joins, gets a bunch of messages, which is how we're able to do this number. When you join, we can test it out. When you join, you leave, you put your name in as Jen, and you get a bunch of messages as you join, right? So that's sort of how that works. The second thing we do when someone joins is we get the total number of messages in a database, and then we go ahead and we push that as well and say, hey, here's what you should show as the total number of messages, and we tag that as total post changed. So the second question is, once someone is joined and they put in a message, right, like, it rained today or something like that, what actually happens as you type this message, right? What's happening in the database that changes, that across the spectrum? What's actually happening there is we have the post change feed that we defined as a worker before, which looks like this. Well, it's just a change feed. We define it as a change feed. And we import a bunch of libraries to make our query language helpful. And then when we initialize, right, this particular worker, we say, go ahead and watch for any changes on the post table, and when a change happens, you should handle that update. The handle update function is a callback that you then use to, if you wanted to, you could say, I only care about the new value, the old value, or whatever you want to do, and you can then pattern match against those things, right, and do some kind of work. If a user's name has changed, do something. If a user's age has changed, do something, so on and so forth. In our case, this is utterly irrelevant because I didn't think this was particularly useful because I was going to just do the same thing I did before, which was if anything at all has changed in a database, get the last 20 posts and send it back, right? And so as a result, you sort of get this sort of changing for free. And then what we also did was we took the total number of posts that are, because the posts have changed, and we sent it back. So if, for example, someone came in and accessed our database and they deleted every single thing in our database, this would then emit a change with the count, right, as well as this current state, which is nothing. And then, as we noticed before, we simply publish these things back to the client, right, as a message that we can broadcast to the room's lobby or the client in this case. So the obvious question is, like, what does this look like on the UI, right? Like, how does Redux handle this? How does React handle this? And what do we get for free there that could be quite useful? So the first place we'll start is in the application, right? So the application, JavaScript application in this case, is simply, one smart component, right? That's the app, right? The entirety of the app, and then a series of dumb components, the message box, right here, the sidebar, which is down here because Bootstrap is Bootstrap, and then the total number of messages below. So what we're doing here is we're simply having a series of handlers for those things, and then we're saying when we render the application, we just have one function that is responsible for rendering, and if it has a username, right, if someone has typed in a username and has now joined the socket, then go ahead and render a message box in the sidebar. If no one has joined because you don't have those props, then go ahead and just render that input field we saw earlier, which looks like this, right? Render an input field. And then, so let's think about what happens when someone, goes ahead and joins the socket, right? So what happens when they put in their name is we have a message, a handler called handle user join that simply dispatches an event called open channel, right? An open channel triggers an action, and that action is stored in the user's the user list of actions, and it simply looks like this, right? It just says open a channel, and then it does a series of things. As you've seen before, open channel simply joins a WebSocket. It passes the username, right, that we've received from the input field. It goes ahead and connects to that WebSocket, joins the channel, blah, blah, blah. If it joins successfully, it then triggers a join channel success action as well, right? So it itself, as an action, triggers another action. However, if it fails, it then says, hey, I failed. What happens, though, if we join successfully is we then do a series of other things. We say, okay, go ahead and watch, right? Set up a series of callbacks for these particular messages. So if I get new posts, dispatch a method called new posts. If the presences change, go ahead and sync the presences with whatever presences I have in the Redux global state in my UI. And if the total posts change, go ahead and sync that as well, right? So in this case, we have a global Redux state for our application, and we're simply setting up a bunch of callbacks so that if anything changes with the application, we just change that, and all the UI components that require that as a property simply just flow, the changes flow down, right? Which is the reason we don't have to do any sort of fancy magic here in our UI components. So for example, let's take a look at the new posts field, right? And as we saw before, new posts is what gets sent to you after you join the WebSocket, right? Or if any changes happen to the post, the messages table, right? So when that new post, trigger comes through on the WebSocket or the channel you're connected to, you simply dispatch a new action called new posts, which looks like this. And that in turn dispatches an action that says, here are some new messages, here are what the messages are, and then here's what it, when it was received. And the question is, how does that change your global Redux state? What happens after you dispatch the action? Well, we have a reducer, right? In this case, we'll look at the messages reducer, and that simply takes an action, new messages, matches against that action, and it takes the value of whatever those messages are, and it updates that global store with it, right? So if there were any other components that require those messages, they would simply get updated. The rest of the application kind of flows like this, right? Like you are joined to some channel. The channel, when some change happens, pushes you a change. And you as the UI are responsible for saying, go ahead and store this in my global state, and any UI components that I have should now just re-render for free, right? And we can dig a little more deeply if people want to into the application, how it kind of works, but like that's the general architecture, right? Is like your database pushes changes to you, or you can request changes if you really want to, and then your server is responsible, sort of that middle point in your data flow that's sort of responsible for either getting things and pushing them back to the UI, or just receiving changes in the database and then handling what that looks like. One thing that I could have done, and I think I probably will do, because I have no life, I like to write code, is you can actually abstract the total changes field that we're using here. You can abstract this into its own change feed, right? And so that itself can live as its own change feed. So when the total number of things changes, then you go ahead and update. So for example, if someone doesn't change the post database, or the post table, but simply updates some particular record, well, in that case, nothing has actually changed in terms of the count of posts. Just one value has changed. So this is a useful case of refactoring, right? Just move something out to its own change feed, and for free, you get a separate worker that can sort of die at will and be restarted. So that's sort of the high-level part of the application. I got a couple more comments before we move forward, but I want to know, anyone have any questions about the application or even the demo itself? Yeah, go ahead.
Which remix library are you using? Because last time I checked, there were two, none of them look like they're under active development, and change views was broken out on one of them.
So I'm assuming you're referring to Elixir, correct?
Yeah.
Okay, so I'm using the ones by Hamilton P. And he broke out the change feeds because it's useful to have supervised change feeds. So if something breaks, like let me say you get a bad change from a database, or you get a change that's like somehow wonky, that worker itself that's watching for changes should like die and restart, right? So I think it was useful you moved it across, but there has been some turmoil. But I think it's been like a year, it's settled. A few talks have been given about it. So yeah, go ahead.
Sorry, not trying
Oh, the guy with the fro.
So when we start scaling, like if the minimalist chat application blows up, what mechanism exists in the Rethink ecosystem to handle distributed clusters, distributed nodes of this shared supervision tree, or like these shared change feeds? If my total post should be the same as yours, even though I'm in Cali, what does that look like?
So this is actually one place where Rethink DB kind of shines, because they have done a bunch of work around scaling, sharding, replicating your database. And so those are two separate questions, right? So the first is what happens to your application server, right, which has many different change feeds, right, watching the database, and then what happens to your database itself. So let's say you had now 1,000 messages per second, like some crazy number that you can't handle, right? What you would do is you would just shard your database, like have all messages from A to H or something like that, and then all messages from some other number, and then all your application servers will simply watch, right, all those as one, because RethinkDB's client allows for you to think about your entire shard or your entire cluster of databases as one, right? You can watch for changes across the cluster as opposed to just watching for individual parts of it. Is that helpful?
Yeah.
And he's asking that question because at Luma we're trying to scale Phoenix right now, so it's going pretty well.
What library do you use for DB and Elixir, and do you have to worry about migration?
Yeah, so that's a good question. There's a bunch of work around migrations in RethinkDB right now. Most people tend to just do them manually or writing raw requel, which is very similar to SQL, but prettier. Then the library I'm using is, like I mentioned, Hamilton P's library, just like github.com/HamiltonP. And there's Hamiltop. Yeah, Hamiltop. And I can show you afterwards, but there are two of them. One, which is just the client, the query language. And then the second is the actual change feeds library that's broken out to handle supervision of multiple change feeds. No problem. Questions, comments, death threats? No? Okay. So the last slide is kind of like further work, right? Because I kind of threw a bunch of concepts at you. It was like RethinkDB, Elixir, things. But the question is like, how do you scale this, right? How do you build applications at scale that this sort of unidirectional architecture makes sense for, right? I think a bunch of stuff to be done to make this make more sense and to be really, really useful. The first is like sockets and redux, right? If you look at the code that I showed you with regards to setting up your sockets to watch, right, for various changes to your channels, it was pretty like hairy, right? It was just like a bunch of callbacks all in one file. So I think there can be some work done around writing maybe even JavaScript libraries that kind of hide some of that messiness away from you. Or maybe there isn't, right? Maybe you want that messiness so that your developers are thinking about it directly. There's also a question about other uses for channels. So like the example I showed you today was typical chat application. This could be the next Slack, right? But there's obviously in our case at Luma we use this very heavily for connecting and talking to Internet of Things devices, right? So being able to tell a device, give me your state currently, or do some task on your device, and then send me back, what the result of that was. That's kind of our use case, or Internet of Things. Service discovery is another sort of use case, right? If you have a bunch of servers, right, who can act as clients, they can wake up and say, I'm a server, and this is what I can do, or I'm a microservice, and this is what I can do. And because of presence in Phoenix, you get that service discovery for free, right? You get the eventual consistency for free, as opposed to having some other server that maintains the state of your current microservice. Analytics is also a big one. So think about a high frequency trading application. Whenever something changes in the world, just push to the client, right? As opposed to polling for it or doing some other sort of high-level mechanism. The third area of exploration is like performance, right? So Marcus just asked this question. Marcus got the fro about performance, right? How do you get performance at scale, right? When you have thousands, millions of users. I think RethinkDB has a bunch of work they've done around that, but it'll be really useful if someone can actually test that and see what parts of the application slows down as you scale up. UI performance is obviously a big deal, right? What happens when you're pushing, not just 20 messages, as we saw in this case to your client, but like 1,000 messages, 2,000, 3,000, right? We can make the argument as it's just JSON, and so it's lightweight, and we can optimize, we can maybe even cache some things, but there can be some work done around diffing, right? Like what has the state actually changed between what the client has currently in the UI and what you're passing back to it, right? Can you diff that in some way? And then can you render the React code in the server so like things are a little faster? And then mobile, there's an iOS client, but there isn't really a good Android one, right? Can we do some work around Phoenix and Android, and what would that look like if you can build your applications in real time and have real-time mobile apps that sort of rely on this infrastructure at scale and kind of have presence for free? So those are sort of the topics of further work, perhaps open source contributions, so on and so forth, and maybe even a talk by one of you in a few months. And with that, thanks to the Luma team, thanks to particularly Daniel Peck, the architect there, who made me start using channels like 3 months ago, and I hated him for that, but I now thank him dearly because it made my life easier. And thanks to all of you for listening. Any questions, comments, or death threats at this point? What's up?
Any good resources you recommend for setting up
PhoenixFramework.org is amazing. Like, it's probably the best documentation I've seen in a long time. And it uses all the Phoenix tasks, very similar to like Rails has like, Rails generate, blah, blah. It has a bunch of tasks that you can just essentially, in like 5 lines of code, generate a channel, generate, a UI, and just start playing with it from there. Yeah, PhoenixFramework.org. What's up?
I know this is the React meetup, but I know Elm is really popular with Phoenix.
Yeah.
Do you know much about what's going on in that world? And could you speak briefly to what you get with Elm that you don't get with React?
So I think for me at least, because before I did Phoenix and React, kind of this stack, I did a lot of ClojureScript and like reagent, right, sort of Clojure world. And one thing I found with both Clojure and Elm from my small exposure to them is you have to learn a new language, right? And that can be tough, right? In the context of this, like you have to learn Elixir, but if you're already using Elixir at work or you're already going to do a backend in Elixir, like you might as well. But if you already know JavaScript, the sort of trade-off with learning Elm or even ClojureScript is you now have to learn like an entirely new language, which if you're doing Node or Angular now is just like an extra level of concern. But also Elm in particular, because it's functional and reactive, it can be tough to learn, especially because it has an opinion about how you should program in addition to how your application should be architected, right? And that combination can be quite stifling. So if you want to build an application, but you already know, like I want to do it this way, I want to use this particular JavaScript library, I would just say go with React and Redux. But aside from that, it's hard to find disadvantages because Elm is so good. So I think if you're going to learn Elm and you are willing to pay that cost, just go ahead and learn Elm because it's really good and perhaps even better than Redux and React combined because it's built for functional reactive programming. Yeah. Go ahead.
You said something that kind of stuck with me. You might have answered this, but I haven't caught it yet. You said don't share anything.
Yeah.
And that's completely counterintuitive to everything that any of us have done. So when you say that, I'm assuming you're referring to certain parts of don't share anything, or are you literally talking about screw it all, do it all separately? So I guess my question is, what part are you referring to when you say don't share?
Yes, so I think that's a great question. So I think there's parts of it that, that require a little more thought, right? So you think about your UI, right? You shouldn't share anything, right? Your UI component should not like explicitly share like something together and be able to mutate that thing. Sort of Redux's way to get around that, because there are 2 ways to get around that. You can sort of say, don't share anything at all, ever, right? Or everything shares the same thing, but none of them can actually change it directly, right? They have to have some other way of changing it that prevents people from doing damage. In the case of React and Redux, Redux is that global state, right? You don't share it between components, but all components rely on it, right? So reliance and sharing are kind of 2 different ways of thinking about it. One is unidirectional and flows down, and the other is sort of like everyone has access to it whenever they want. And
Basically say everything to be a consumer.
Exactly. That's precisely the thing about RabbitMQ, right? Like, there is, there are consumers and producers, and the consumers are explicit about not, being able to directly mutate the state of that. They just sort of take from it. In the case of Elixir and Phoenix, it kind of goes all the way down to the language, right? Like, you can't even, so like in JavaScript, you can say, define some variable, right? And then 2 lines down, you can like change the value of that variable. You can't do that in Elixir and Phoenix because like it's a functional language, and so you can't even change the value of a variable, right? It's always new, and it's never shared. And in the same context, processes can't share state unless you set up some, other way for them to share state, like a database, right? In this case, or like a small cache, which Elixir has a concept of. So that's what I mean, is like, don't share, but if you're going to share, think about it more so as reliance. So there's a flow to consumers rather than everyone sort of fighting, because otherwise you have locks, semaphores, and these sorts of problems, or general problems around concurrency, right? You can't scale concurrently if everything is making changes to the same sort of state. Any more questions? Cool. Well, thank you.
Don't stay too long. They want to kick us out at some point, but make sure all the pizza and beer gets eaten and drank.
3 months.
3 months.
Yeah.
I interviewed actually there.
Oh, really? What's your name?
Daniel.